Hello, let's talk about how to simulate athletic performance using note cards and technology when we're given two different proportions. So if we have an example, this is the Cardinals data once again. If we have 6 wins at home, 3 wins on the road, when we're simulating with note cards, we actually use the totals. You have to describe each of the totals in order to simulate with note cards. So what that means is this grand total here tells me the total number of note cards. So for example, I would say using 16 note cards. That's not how you spell note cards. Okay, so using 16 note cards. All right, that's step one. Now we have to talk about how many note cards are labeled, or what are note cards labeled. So just like what we did for the random number simulator in step one, we said how many total numbers am I simulating, what are my categories or what are my ranges of data or my regions. So we've got to identify what our regions are going to represent. So the way that I do that is I say, okay, I'm comparing my wins versus losses. So these are going to be how I'm going to label my note cards. Label my note cards because I'm trying to replicate the number of wins that I had at home and wins I had away. So label note cards. That means that I'm going to say let 9 note cards be labeled with a W for win. W for win. And let 7 note cards be labeled L for loss. Okay, from there, I'm going to use these bottom totals because those are the amount of games that I want to replicate at home and on the road. So let's change the color. I don't want to use the same color, so purple. All right. So I'm going to say shuffle and deal 8 cards for home or into the home pile and 8 cards into the away pile. And it's okay for all these numbers to be different. I could have played 10 home games and 15 road games. They can all be different. The last thing you want to do is you want to create your test statistic. You're trying to replicate the test statistic, so we're going to calculate the difference in proportions or difference in performance. So I'm going to say difference in proportion, record on a dot plot, and repeat many times. Okay, so we have 16 total cards. That's from the grand total within my two-way table. I label 9 of those note cards with a W for wins, 7 with an L for losses. I shuffle and deal them into 2 piles, 8 cards into my home pile, 8 cards into my away pile, and I calculate the difference in proportion. That's my simulated test statistic, record on the dot plot, and repeat many times. So we're going to actually practice this in class. Okay, so just kind of a couple things to think of. If I get that they win 4 out of 8 games at home and 4 out of 8 games on the road, when I calculate the difference in performance, I'm going to get actually a 0%. So a 0% would mean that we were able to, that they won the same percentage. We had a simulated winning percentage for both home and away that was the same. All right, let's say the same simulated winning percentage for both home and away. If I got a negative 100%, so it's okay to get negative 100, because I'm subtracting home minus away, if I were to get that they won 0 out of 8 for home and I subtracted that they won 8 out of 8 for away, that means I would get negative 100. So that means they'd won every game away. So they had a higher percentage away. And if we had a positive 100%, you would have a higher percentage at home. Okay. So we can also get this simulated dot plot from an actual site. So you're going to have to be able to do this for your investigation. So it looks like this when you pull it up. It's a difference in proportions. This would be your number of wins at home in context 1. If you're saying you have a greater ability to win at home than away, then we're doing home as context 1, away would be context 2. So you plug in your information here. So let's say they want, I think in this case, let's go back to our graph. So we have that they won 6 at home out of 8, and they won 3 at home on the road out of 8. So 6 successes out of 8 attempts. Here they have 3 successes out of 8 attempts. Okay, the observed difference in proportion, that's my test statistic that I'm testing it on. So you'll see that 0.375. I press simulate 100 differences because I want 100 trials of simulation, add more, and it's going to create this dot plot for me. And the dot plot's going to show you those simulated differences, where the positive values will be simulations where you performed better at home, and the negative values would be simulations where you performed better on the road. Okay, so let's just try one more example together. So this is Chicago Cubs baseball game. They're the last stadium to add lights to their field, or last, field. So I'm simulating the difference between wins during the day and wins during the night. So again, you always want to use your grand total. So how many total note cards are you going to actually simulate? So we have 82 total note cards. Okay, you're going to label how many of them with a win? But it's going to be 45. You're going to label an L for loss. That's going to be 37. You shuffle and deal into 2 piles for day and night. Day pile will be 63. And your night pile will be 19. So I want to make sure that you see every one of those 5 totals in your description in order to get full credit. The last step is you want to talk about how you're going to calculate the difference in performance, record on a dot plot, and repeat many times. All right, good luck simulating. I hope this in-class activity where you're actually shuffling the note cards helps to be a little bit more concrete in your head. Let me know if you have any questions.